Welcome back to Maths with Mrs. J. I wanted to talk about sketching quadratic functions. And as I do with any sort of function, I want to think about our basic garden variety version. And then I want to think about how slight changes to the formula can cause us to adapt the graph accordingly. Pretty much whatever graph you're talking about, whether it be a quadratic function, a trig function, whatever, the same sorts of things start to happen. And you will find if you multiply out the front by a negative, you will turn things upside down. If you have an x minus something in brackets, you'll tend to shift something to the right by that amount. If you have a plus or minus something, it'll shift the whole thing up or down, that sort of thing. I wanted to actually do a bit of an investigation of our basic y equals x squared and the various small changes that we've made here, like y equals 2x squared, etc. If we have y equals x squared, then what we're saying is we need to, if x is -3, we need to do -3 squared, which is 9. -4 squared is 2. -1 squared is 1. 0 squared, of course, is just 0. 1, 4, 9. Clearly, we're not going to get a straight line if we're graphing y equals x squared. What we get is in the shape of what's called a parabola. So we'd have something like this. So -3, 9, -4, sorry, -2, 4, -1, 1, 0, 1, 1, 2, 4, 3, 9. That sort of thing. We want to get a curve. We don't want to use a ruler to go between. So we get something like that for y equals x squared. Okay, let's consider what happens if we have y equals 2x squared. Well, it's going to be the same as x squared, but we're going to multiply everything by 2. So instead of 9, we're going to have 18. Instead of 4, we're going to have 8, etc. Let's see what this one is going to look like when we graph it. So -3, instead of 9, it's going to be up at 18. -2 is going to be at 8. -1 is going to be here. We're still going to have 0 here. 1, 2, 2, 8. And 3 at 18. You can probably even see by the dots that this is going to give us a steeper parabola. You could think of it as a skinnier parabola if you like, but in mathematical terms, you could say that it is increasing at a faster rate. So we try to get a smoothish curve happening. It's not easy to do, which is why using a pencil is a better idea than trying to do it like this. But anyway, so that's our y equals 2x squared. What would happen if we wanted y equals -x squared? Well, what we're going to get is whatever we had here, but make it negative. Just bear in mind, -x squared is very different from -x squared. This one is what we want, and we want to square x and then make it negative. So all of these we want to make negative. So when we plot these, what we're going to get, coming down here, you get something like this. Again, I'm just doing this very roughly just to give you a rough idea of what it's going to look like. And we're going to get the same shape as we started with in the green, but it's upside down. Okay, what's going to happen here? So what this means is, it means take your x value and take 1 away from it first and then square it. So -3, take 1 away as -4 and square it and we get 16. -2, take 1 away as -3, square it and we get 9. -1 minus 1 is -2, square it and we get 4. And what you've basically got is this shifted across. So if we do that, at x is -3, we're going to get up here at 16. At -2, we're going to get 9. At -1, we're going to get 4. At 0, we're going to get 1. At 1, we're going to get 0. At 2, we're going to get 1. And at 3, we're going to get 4. So what's actually happening here is we get the same as we started with originally, but it's being shifted across to the right by 1. So this is, in theory anyway, the orange is meant to be the green one shifted to the right by 1. So this is y equals x minus 1 all squared. Okay, and our last one for this video anyway is our y equals x squared plus 1. So we just take our normal x squared and we add 1. So it's fairly easy to do. So here's our normal x squared. We're just actually, each of these values is going to go up by 1. So get something like this. So this is our y equals x squared plus 1. Now, yes, that does look a bit of a mess and I do apologise for that.